from the previous section, we learned how to find the maximum rainfall or desired rainfall. The next step, we have to convert from the maximum rainfall to peak discharge. Okay, so we use this method we call the rational method. It's a basic and simple method. This is Q peaks. It means the peak discharge is equal to CIA. Okay, QP is a peak discharge in terms of cubic meter per second, and C is runoff coefficient, and I is mean intensity of rainfall. Okay, if unit of the if we use this equation, it means unit of the Q peak is cubic meter per second, and I is a unit of the millimeter per hour, and for the area, unit of area is square kilometer. So, and we use this factor to convert from millimeter per hour times square kilometer to get this to convert to cubic meter per second. Okay, and for the rainfall duration is equal to Tc. Okay, Tc, what's the meaning of Tc? Tc is we call the time concentration. So time concentration definition is equal to the meaning of time concentration is travel time from the farthest point to the catchment outlet. Okay, it's travel time of water flow, and normally from on the surface from the farthest point. Also, it means its largest length to the outlet. Okay, and L. This one is just one example of the using the Kerpit equation to find the Tc. Is function of L and S. L is the mean the maximum length of travel time unit in meter, and S is a slope unit in the unit in dimension as units. Okay, and for the runoff coefficient, C is depend on different land use, different area. I forgot to put this table, so I just show below, show some example of the C for the launch, for the urban areas, for the sandy soil, for the flat area, it's about 0.05 to 0.1, but on steep it is increased to 0.15 to 0.2. But for residential area, is single family area or single house, increased to 0.3 to 0.5, but in the multiple unit, it increased to 0.6 and 0.75. Okay. Actually, C we can explain like this. C is like the ratio between output and input. Okay, if C is 100%, it means output equal to input, but normally C is less than 100% or less than 1. Okay. The next example, an urban catchment has area of the 85 hectare. So 85 hectare is equal to 100 to 100 square meter. Okay, this one is a square meter, so we can convert to square kilometer. It's about 0.85 square kilometer. The slope is equal to 0.006, and the maximum length 150 meter. The maximum depth of rainfall with the 25-year time period is in below table, is the table between duration and depth of rainfall. Okay, and given the runoff coefficient is 0.3, so we estimate Tc from the Kerpit method. Okay, substitute that this as constant, and the length power 0.77, and the slope just leave one. 20. So we got about 77.39 minutes for that. And the next we find the depth of rainfall from above table. We can do interpolations, so the TC is somewhere here. So we have to find the depth of the rainfall by interpolation. Got about 47. Okay, the next we find the average intensity is equal to, convert to millimeter per hour, so we divided by the duration is times 60. So if we convert to millimeter per hour, we got 103.8 millimeter per hour. And the next we can estimate Q peak equal to 0.278. Okay, substitute. C is 0.3, I is area is 0.85. So we got the Q peak is 7.35 cubic meter per second. Okay, so now we can estimate from the maximum rainfall or desired rainfall in the IDF curve, we can convert to Q peak, and the next step we can use this for decide the pipe flow, the conducts to drain this peak flow or decide speedway